Hey everybody, today we're gonna solve a question, an introduction to chemical engineering, and the question is that there is a compressor that receives shaft work at a rate of 90 kilowatt and experiences a heat gain of 10 kilowatt. The steam flowing at a rate of 15 kilogram per second that enters the compressor at a velocity of 40 meter per second and leaves at a 0.7 meter below the inlet at a velocity that is 7 times the initial velocity. He needs to find out the rate of change in the enthalpy of this process. So the first thing you have to put in your mind that you have to read the question more than one time to solve it correctly. So let's figure out what we have in this question. So he said that the compressor receives shaft work at rate of 90 kilowatt. So if the compressor are receiving work, so the work here is done on the system, on the compressor. That means the work here should be in negative. So the work is equal to minus 90 kilowatt. And experiences a heat gain of 10 kilowatt. So heat here is coming into the system. So the heat is gained. So Q should be in positive. It's 10 kilowatt. Steam flowing at rate of 15 kilogram per hour. So the steam flowing at this rate means that the mass flow rate for the steam is 15 kilogram per hour. Enters a compressor at a velocity of 40 meter per second. So the inlet velocity was 40 meter per second. Leaves at a 0.7 meter below the inlet. Okay, so this is the outlet point. So this is the outlet point. So we could assume the point as Z. So Z out is equal to minus 7 because it is minus the inlet point. We could assume that the inlet point, which is Zn, is equal to 0 and it's below the 0, so it should be minus 7 meter. And at a velocity that is 7 times the initial velocity. If the initial velocity was 40, so the outlet velocity should be 7 times 40, which is equal to 280 meter per second at this point. Okay. He needs to find out the rate of change in the enthalpy. So the unknown here is delta H. Okay. So the question is easy. We just need to be sure about our answer. So we don't need this because we have all the information here. We know the formula that say that a Q heat minus work equal to the change in delta H plus the change in the kinetic energy plus the change in the potential energy. This one is known, and we can find this one from the change in the velocity, and we can find this one from the change in the point that is inlet and outlet. And that's easy to find because we have the mass here for the kinetic energy, and we know the gravity, we know the mass here also is unknown. So we can find this one and this one from the formulas. So let's go and find out what delta K, what was changing, the change in the kinetic energy is, which is equal to half mass multiplied by the V velocity out squared minus velocity n squared which is equal to half. So we have to be careful about the units. The mass here in kilogram per hour, and the velocity is in meter per second. So the units of time is not the same. So we have to convert, this one, for example, to seconds, which is, we have to multiply it by 1 divided by 3,600 seconds. And then we can find out the mass, which is 4.167 multiplied by 10 to the power of minus 3, which is kilogram per second, multiplied by the velocity out, v out, which is 280 squared minus v in, which is 40 squared, and this is in meters squared over seconds squared. And then we can find this one, which is equal to 160.0 whatever. This joule per second, so it's joule per second. We have to convert it to kilojoule per second because the heat here and the work here is in kilowatt, so it is 0.160 kilojoule per second. And for the potential energy, it is mass time gravity time the Z out minus the Z in, which is the out point and the end point. And this is equal to 4.167 multiplied by 10 to the power of minus 3 in kilogram per second, multiplied by 9.81 meter per second square, multiplied by the Z out, which is minus 7 minus 0 meter. So this is minus 7, and the answer here is minus 0.286 joule per second. If we need to convert it to kilojoule per second, it becomes minus 2.86 multiplied by 10 to the power minus 4 kilojoule per second. And then we can find the delta H, which is equal to heat minus work minus change in the kinetic energy minus the change in the potential energy, and that's equal to plus 10 kilojoule per second plus, because it's minus 90 kilojoule per second, and minus the kinetic energy, which is 0.160 kilojoule per second, and plus minus 2.86 multiplied by 10 to the minus 4 kilojoule per second. The answer should be equal to 99.84 kilojoule per second. This is the delta H that what we need. And this is the end of the video. Thank you for listening. I hope that you understand. Thank you.